Good morning, COM 3928. Dr. Mueller here just after 10 a.m. Saturday. Looking out the window, we're getting nailed with another snowstorm. Most everything up here on the mountain in Boone is closed. So I'm in here doing work, which I enjoy anyway. Probably go for a walk at the rec center track in a bit. But today, more fun in research. I enjoy these two tests. Again, I think they're more revelations about what our data tells us. And remember, in advertising, what we want to do is go back to the client and demonstrate we have inferential results, right? We can infer things, and we want to show the client what we know, what we learned in the results, and once again, then in the end, recommendations for advertising and marketing, right? And also remember, in the end, in the final project, I want to see some detailed written notes, like report style notes in a PowerPoint deck. And I'll tell you more about this, but the entire presentation should be all visual, infographic. We want very strong visuals, a slide deck, PowerPoint, Visme, whatever you want to use. Go ahead and set it up, okay? But the point is, it's got to be easy to understand and visual for the client. We don't want to load up a slide deck with all kinds of words and bore them or lose their attention. Okay, so today we're going to talk about, I would call contingency tables another descriptive test, really, because they're just showing us a really interesting combination of, if we look at a respondents and how they answered one variable, and we look at the respondents and how they answered another variable, where, as they answered 1 to 7, where are the big chunks that are combined, where people answered similarly? Okay, we can sort of identify clusters of people. What's really fun about this is we're going to use this on the same pairs that we found were correlated in our correlation testing. Okay, so for the assignment, let me pull that up and we'll start there. How about that? Let me capture. That means 1 second. Let me make sure I got everything running okay here so you can see what's going on. All right. Capture main screen. All right, here we go. So here's the next assignment, and I had it hidden. Let's go ahead and I'll go show. All right. Contingency tables and factor analysis. Okay, so here's what we're going to do. Click it in and open it up. Contingency tables are a great complementary test to what we know as correlation, okay? We know two variables were highly correlated as pairs, right? Or correlated, we reported on that, right? Which ones were highly similar in how people answered them, either positive, up and down together, or we had one negative relationship. One goes up, the other goes down, one goes down, the other goes up. I mentioned you might think about that as pushing away against each other, right? So we did all that, good job. Now we're going to go inside those variables and say, okay, now that we know they're correlated, how were people answering? What do we learn about inside those correlated pairs? Okay. Then second, we're going to do factor analysis. That's more fun. We're going to remember there's 6 answers, 6 items under each of all the visuals we gave them, right? Here's a visual of Instagram. Here's 6 responses, right? Here's a visual of a power bill. Here's 6 responses. Remember, out of those 6 responses, they're measuring different things. The way the theory goes, and the way we pull that out of that guerrilla marketing millennial paper, remember this: creativity was captured by the 2 items. It was fascinating and had good ideas. Remember, those were 2. Under clarity, there was the ones easy to understand and very clear. Remember, and then out of the third pair out of the 6 was credibility. It was sincere. It was trustworthy. All right. So remember, when we use those, the idea was each 2 would capture a certain dimension of how people were thinking about the response. Okay. Factor analysis tells us, did those dimensions hold up? Did that scale work like we wanted it to? Factor analysis looks at all the patterns of all the answers among those 6. Okay. My mentor in University of Florida taught me, picture dots in a room, 3-dimensional dots in a room, and they're all twisting and turning, and JASP is looking for the best fit among different ones of those variables, and it clusters them. It shows us which ones among the 6 stuck together more similarly. Okay, so we're going to factor through the 6 responses for each of our visual cues and find out, did those 6 items hold up 2, 2, and 2 like we thought they would for creativity, clarity, and credibility. Okay, fun test. Okay, so in the video, I'm going to show you how to do this. For this test, for this assignment, you choice of 3 of the correlated pairs, your choice. Any of the 3 correlated pairs, you'll do the contingency table for. And then for factoring for this assignment, I believe we're going to do 2 of them just for this. And let's see, it's in here somewhere, I believe. Energy bill and Instagram. Just do those 2 for now. Now in the final assignment, and I'll make this all very clear, the final project, you're going to run tests for everything. Some you won't report much on, but once you learn this, it takes a couple seconds to run a test, right? It's pretty fast. You capture what makes sense and what means something. That's what you'll report on. But each of these assignments, we're sort of testing each one, getting to learn how the test runs. Final project, you'll do all of them and all the combinations. All right? So let me do this. JASP, Energy Messaging Survey. Okay, I'm going to show you a contingency table. Actually, I think I had one here already, but let's start over. I'm going to do something I'm going to remember the big 8 we're talked about, the big 8. Let's just do those for the contingency table. And remember, in your assignment, you're going to be running together correlated pairs. So let me go frequencies, contingency table. Okay, that's where you start. Frequencies, contingency table. Rows and columns. These are the only 2 you have to worry about. So in this, again, I'll go down. This isn't what we did. We did some correlated pairs. Let me pick something here. And I don't remember if this is correlated or not, but I'm just going to pull a couple together here and see. So I'll go find energy web page in one row, and then I want to compare that against, how about Instagram sincere? Just doing this to test, okay? So look here real quick, simple. Here's the contingency table. Down this way, here's how think of all the respondents. What do we have? 388 in this test, 388 respondents. Among the people who answered find info on a web page, here's the 1 through 7 answers for that, right? That was the web page question. I really like web pages, and for that, I think that's the one, very untrue of me, very true of me. Okay, these are how everybody answered 1 to 7, and these are how everybody answered Instagram sincere. Okay, now remember, for your test and the assignment, you're going to be looking at any 3 of the correlated pairs that we already tested for, right? And you move them in one at a time, not all of them at once. Just pick your 1 pair, move it in, and test. All you need to do here, and this is fun, look across this whole table. And where do you see the biggest numbers? It tells you about your respondents. Well, look at this just by glancing. If the biggest number is 35 out of my 388, 35 people felt finding info on a web page, that was very true of them. And then you go over here, is Instagram a sincere response? They answered 5 on that 7 scale. Okay, so in your correlated pairs, you're going to be able to look at that and say, okay, where did the people fit together on some of these answers? Where did the most of them seem similar? And you can report on, let's call the top 2 or 3 biggest numbers here, but it starts telling us among our groups, where do people fall in? And when you look at this on correlated pairs, it's going to make sense because you want to find more about why is that pair of variables correlated, and then what inside that group through the contingency table, how are people thinking? Are they real strong on one part of that variable and real weak on another? You can examine that. That's it. It's just visual. It's basically descriptive, right? There's no inferential in this. It's just showing us combinations. Does that make sense? So that would be a contingency table, and you'll run those, do screen snips, and then write a report. Just write about what you're finding among, the biggest clusters of people. What are they thinking among the correlated pairs? Okay, now, factor analysis. You go up here and click factor and exploratory factor analysis. Okay, that's going to pull up a whole new thing here, right? And I want you to do a couple of things. Orthogonal. I'm not going to go into this a lot, but just click Varimax. Okay. This is called rotation. And the way I was taught is JASP is taking all these dots in a room and it's twisting them, rotating them, trying to find the best fit. If you look down orthogonal, these are all different types of rotations. Okay, it gets a little complicated. I've used Varimax a lot. I think it's in social science, it's used a lot. So click Varimax, okay? Again, as it rotates, it's going to look for dots to fit, okay? Most of the time, many times in factor analysis, we look for eigenvalue is the power of the cluster. Eigenvalue is the power of the cluster. But for this test, because we're looking for 3 dimensions, right? That's what we're trying to find out. Did the 6 cluster into 2, 2, and 2 like we intend? Let's do this. Click Manual, Number of Factors 3. And what we're saying, that's called like forcing it. You're forcing 3 factors because as JASP figures this all out, it's going to push them into 3. Ordinarily, it might not go that way, but I want you to test to find out if they stayed together like we wanted. Okay, output options. Leave this at 0.4. That's really the factor loading. This leaves it, it just shows you which ones are factor loaded at a certain level. That works well for us. Okay, 2 more things. Path diagram and scree plot. Okay, so here, orthogonal Varimax, manual number of factors 3. Leave this at 0.4. It should come up that way in your test. And then path diagram, scree plot. That's the settings. Okay. Now, I'm going to pick, we're not testing these, right? But I'm going to go back to the big 8. And I'm going to factor these. You're not factoring that. You're only factoring the clusters of 6. But I'm using this for a test. Okay. So I'm going to grab the big 8 and put them in here. Okay. So, and then let's see. Okay. And it should run this test for me. Okay, well, look what happened here. For the big 8, and I think this is interesting too, here's it. This is, cluster 1, factor 1. This is factor 2, and this is factor 3. Now, looking across, factor 1 collected Instagram and Twitter. I don't remember. Is that a correlated pair? Remember, in correlation, I think those 2 might have been correlated. Well, here, of course, they cluster into a factor. Again, they're similar. Factor 2 collected U.S. postal and energy bill. Doesn't that sound familiar? I'm pretty sure we had that as a correlated pair. So this is the clusters. Then all alone over here is find info mail. Now, if you notice, this only picked up 1, 2, 3, 4, 5 because it only wants to pick up ones that are strong enough, okay, to fit in somewhere. So when you see yours, look across that and see if you see 6 and see how they fit into each of those factor categories, okay? Now, scroll down here. This is a visual of what happened, okay? Factor 1, that's here. Instagram and Twitter, almost like network. Big green lines are strong. Little lines are, green lines are weak. Red is, opposing. So here we see visually. Find info Twitter, find info Instagram. Here they are, collected strong, right? Not too strong, but still. Find info energy bill and U.S. postal. That went into factor 2. And then find info email is alone in 3. Those are the way it's sort of clustered. Some of these other ones you can see they're real weak, but they don't show enough to grab it. Does that make sense? Last thing in the test. I mentioned to you before about eigenvalues, okay? And in our testing, we usually say eigenvalues are about more than 1, but here's all I want you to know. Eigenvalue is the power of the factor. And all you need to do here is you look down these dots. Dot 1, that's factor 1. Dot 2, that's factor 2. Dot 3, that's factor 0. This is the power. So 5, 1, 1.5. This is factor 1. Let's call that eigenvalue 2. Okay? And then this is factor 2 here. Let's call that eigenvalue 1.5. All I'm saying is look at the measure here is strength. Here's a 0.2 eigenvalue. Here's a 1.5. And then this one here, this third factor standing alone, 1, 2, 3. Well, that's about, I don't know, 1 1/4 or something. Okay, so look at these dots based on this scale. It tells you the power of each of these factors. That's something else I'd report, or you should report. Okay, so again, we'll do this. You look for, put 6 at a time in here, right? Factor exploratory. So remember, when you're back up here and you're starting over, you'll grab, I forget which ones I told you to do, but here's, here's 6 for energy bill, here's 6 for Instagram. You do them 6 at a time, and then look at how they factor. Did you get the 3 clusters? And if you did get 3 clusters, look at the list of what words are supposed to go in each cluster to tell you our 6-item scale held up like it should. Okay, so for this on the assignment there, I think you're going to run 2 of those, right? Do the screen clip, show me you ran it like this, and then report. Did it hold up or not? It's in this test, we're not really looking significant or not significant. We're just observing what happened. Yes, it did. This, 2 words were here, 2 words were here, exactly like the scale, it held up. Eigenvalue on this one was this, eigenvalue on this one was this, eigenvalue on the third one was this, showing the power of each of the factors. Okay, and then you've got the visual to help you understand. Okay, if it didn't hold up exactly like we think it should among the 6, 2, 2, and 2, report what happened. Where did they cluster? What did it tell you about which items of the 6 pulled together into the clusters? Okay, just practice. For the final project, we'll run each of the 6 for each of, the visual cues, and then we'll go from there and report. Okay, so you'll get the idea here, and in the final project, yes, a lot of testing, but as you learn how to do these, you can move in and out of a test really fast. Okay, so we'll do that. It's a great practice, and that is looking at contingency tables, once again related to the correlated pairs we already tested for, and then factor analysis showing us among the 6 variables under each visual cue, did they cluster into the 3 groups we wanted them to, representing, creativity, clarity, and credibility. All right, that's it. I say it every time. As usual, questions or comments, let me know. And as usual, please start on this right away. I don't want anybody getting hung up because of tech problems. Okay, if you have problems, you want me to help you interpret, I have students in this class, in this cohort, contact me quite a bit. It's fine. And I told one student, don't apologize. Don't apologize for contacting me. Contact me. Just give me time. Don't jam up 4 hours from deadline and everybody comes in with problems, okay? I will help you always. Just give me the time. All right, thanks a lot. Bye-bye.